Units and measurement. Summary. Hello students. Let's go through the summary of units and measurement. This topic forms the very foundation of physics, as physics is all about measuring and quantifying the natural world. Let's break down each point for clarity. 1. Physics as a quantitative science. Physics relies heavily on measurement. We measure physical quantities like length, mass, time, electric current, temperature, amount of substance, and luminous intensity. These are known as fundamental or base quantities. 2. Units and their importance. Each of these fundamental quantities is measured against a standard reference called a unit. For example, meter for length, kilogram for mass, second for time, ampere for electric current, Kelvin for temperature, mole for amount of substance, and candela for luminous intensity. These units are known as fundamental or base units. 3. Derived units. Now, what about other physical quantities like speed, force, or energy? These are not fundamental, but are derived from the base quantities. For example, speed is derived from length and time. So, its unit is meter per second. These combinations of base units form what we call derived units. 4. International System of Units, SI. The most widely used system of units across the world is the SI system, or International System of Units. It is based on 7 base units, which makes it standard and reliable for measurements globally. 5. SI units for derived quantities. All physical quantities, whether fundamental or derived, are measured using SI units. For some derived units, we even have special names. For example, force is measured in newtons, energy in joules, and power in watts. 6. Symbols for SI units. The SI units are represented by standard symbols. For instance, meter is represented by M, kilogram by kg, second by S, ampere by A, and so on. These symbols are internationally accepted and must be used correctly. 7. Scientific notation and prefixes. In physics, we often deal with very large or very small numbers. To simplify notation, we use scientific notation which involves powers of 10. For example, instead of writing 0.00000001, we write it as 1 multiplied by 10 raised to the power of -7. Additionally, prefixes are used for convenience. For example, kilo represents 10 raised to the power of 3 or 1000, mega 10 raised to the power of 6, micro 10 raised to the power of -6, etc. 8. Rules and guidelines for notations. When writing physical quantities, we must follow certain standard rules for notations and symbols. This ensures uniformity and clarity in communication. 9. Algebraic treatment of units. When we compute derived quantities, we treat their units algebraically. For example, when we calculate speed using distance and time, the units are divided just like numbers. If distance is in meters and time is in seconds, the speed will be in meters per second. 10. Significant figures. Measurement accuracy is limited, and we express this accuracy using significant figures. The rules for determining significant figures, handling arithmetic operations, and rounding of numbers are all important to maintain precision. 11. Dimensional analysis. Finally, an important tool in physics is dimensional analysis. This technique helps us check whether an equation is dimensionally consistent. For example, if you derive a formula for speed, it must end up with dimensions of length divided by time. Remember, if an equation is dimensionally incorrect, it is definitely wrong. But if it's dimensionally correct, it may still be wrong. So, dimensional analysis is just a first check, not the final proof. This summary covers the essentials of units and measurement. Understanding these fundamentals is crucial as they will be applied in all areas of physics you will study later.